Okay. I am very much looking forward and I'm very much excited about this next presentation by Jamin Hu. He is the co-founder and CTO of Doublepoint, and he has some very exciting things to share with us today. So without any further ado, Jamin.
Thank you very much. Thank you, Louis. Thank you, or Louis. Yeah, cool. Thank you. Thank you very much. Thank you. Thank you. All right, let's see. So I think if I go into presenting mode, probably the AV guys could set it up so that they can see things. Oh, wow, okay. All right, great. Oh, is it this? I think it's this. Wait 1 second. All right. Just give me a second. Oh my, you can see I'm using Firefox. F11. It's F11, right? Oh, it's not working. Okay, anyway, well. Yeah, maybe I should just start off straight by diving into the demo itself. So actually what I have here in front of me, as you can see right now, oh, there we go. Okay, so on my watch is the Samsung Galaxy Watch 4. And what I have on it is actually our Doublepoint algorithm, which is able to detect the exact moment you touch your fingers together to select. So if you just look at my wrist here, like here right now, when I touch my fingers together, it seems to be able to detect it. So it senses the vibrations using onboard sensors, existing sensors, basically the IMU and the PPG. And with our algorithm, it can transform that, and exclusively that, into input events in real time with computation on the smartwatch itself, which means that if I combine it with let's say, so I'm just going to show you now, if I use the watch's IMU to also know where I'm pointing, I can actually have this general purpose point and select interaction without the cameras at all on the headset. So I can block the cameras, for example, and you'll see the ray still works. So I could just select like that. And so yeah, now your camera, your headset, if you're a headset manufacturer, you don't need cameras or computation running on your headset all the time to figure out where your user is pointing and selecting. So that's one thing. And the second thing is, if you really want, you can combine it with eye tracking to make the ultimate point and select device. You literally just look at where you want to select and you tap your finger to select. You don't even need to lift your hands. You can do it anywhere. No one would know you're doing it. So yeah, I think these are the two main things you'll see quite a lot in the rest of my presentation. Yeah, so as Louis said, my name is Jamin Hu. I'm the CTO at the touch interface company Doublepoint. Yeah, we were founded 3 years ago to try to solve the AR interaction problem in general. So to try to move away from controllers and hand wavy pokes of the HoloLens and the Quest Pro and anything with hand tracking to more intuitive micro gestures, the sort of stuff that, like I showed you earlier, I didn't even need to lift my hands. You can't tell what I'm doing. So the purpose of me being on stage here today, just to be explicit for everyone, is that personally I am pretty interested in sharing things that I'm working on, and I feel like you guys might be interested in this too, if you're here. But the second one, and probably more important for the company, is that I'd like everyone that's trying to make headsets right now to know that we have a few input solutions for you, especially if you're having trouble fitting everything into a small form factor that everyone can use in their everyday. So I think that's the point. That's a very important point here. So what's, and I just want to highlight here that, oh, is there anything on stage? Oh no, okay, 1 second. Sorry about that. I'm fine. Okay, great. So yes, I want to show you these interactions which are intuitive, discrete, and low cost. So you shouldn't need to sacrifice the usability of your headset if you want to make it shapely and things like that. So this is for you guys in mind, if that's what you're looking for. So here's what I'm thinking about the structure for today. So we'll start up by finishing up this intro. I'll give you a little bit about how we think about interactions. And then mainly I'll be demonstrating and explaining the 3 interaction paradigms that I think would be important for you guys to know based on this touch sensing from a wristband. And then in the end, I'll leave plenty of time for questions because I think the discussion would be fun. And of course, in between, I'll explain how this all works. Yeah, and now before we dive any deeper So to finish up the introduction, I'd like to acknowledge that, of course, there are other options out there to input into AR. There's voice, of course. You just saw in the previous presentations, if you were here. There's voice, there's head gaze, there's eye tracking, and there's hand tracking in general. But we wanted to, at Doublepoint, start from the ground up and sort of look at all the good solutions and look at what we have in common amongst all of them. And right now, I think I want you all to know that what we think all of these solutions have in common is touch. So we think that touch will keep being an integral. Okay, I'm not sure if that's right grammar, but will keep being an integral part of interfaces, of good interfaces in the future, just as it has been since the beginning of humans calling ourselves humans and using tools. So with that. Any questions, or shall we move into demos in more detail? Oh, there was a whoop. Okay, so interaction paradigm number 1, raycasting, so this is basically what you saw earlier. So the premise. Just a second, I need to do this sort of acrobatics. There we go. Okay. Oh. There's some rendering issue right now. Okay, well, so my main point here is to show you that raycasting works without the need for cameras, and specifically, it works even in terrible lighting conditions. So my hand also doesn't need to be raised up over here. It could be very low, like this. I could, for example, pop a bunch of buttons, a bunch of bubbles like this, and I can move around, and the ray stays where it's supposed to stay, and like that, and I could be walking, and it would still work. This is basically the idea behind it, and what we're trying to basically tell you. Is that you don't need cameras or hand tracking algorithms. You just need a piece of software that goes on smartwatches with existing sensors, and that's the point. So if anyone has a wristband that has an IMU and a PPG, it doesn't even need to be a full smartwatch. Even Fitbit could do this. So Fitbit could install our algorithms on it and could turn their Fitbit wristband into an interaction device. And let me just try to move on to the. There we go. Okay. Yeah, so how does it actually work? And let me just go into a bit more detail here. So the point and select has 2 parts. The pointing is done with the 3DOF ray that comes from the IMU. Now there is a subtlety here. It's not just a straightforward 3DOF. We do some drift correction, and we have to sort of recenter the ray very naturally so that you don't have to press a button or you don't have to shake your hand, but all you have to do is you literally lift your hand up and it centers where it thinks you're facing and where you want the ray to be. So that's one key thing that needs to happen for this to work. And the second part, which is, I think, the most important part, is that you really need to be very good at detecting exclusively the exact moment you touch your fingers together and nothing else. So this, and I want you to think about it like this, that we're using the same IMU that we use for this 3DOF ray positioning, but now we use it to detect the subtlest vibrations that happen when you touch something and sense vibrations. It does this at 100 hertz sampling frequency with 100 millisecond latency at max. And the model size, the machine learning model here that is used for it is at max 1 megabyte in size. So it's a pretty small model, and it can go even smaller than that. No calibration or minimal calibration also is sort of expected here. And so it has to do all of this while also being pretty robust and sensitive with minimal trade-off between the two. So for example, it should sense super light taps so that you can tap as lightly as you would tap on a hand tracking system. But even then, it should maintain robustness and refrain from triggering when you're going about your everyday or touching other things like a table. So if I touch the podium here, it shouldn't trigger. And if my hands are on the lap, it shouldn't trigger. And if I try to trick it, it shouldn't trigger. But then when I tap my fingers together, it triggers. So wow, magic. Oh, wow, thank you. Yeah. Yeah. So actually, I'm a magician. No, I'm kidding. So, welcome to Doublepoint. We are a magic company. No, sorry. Yes. So, yeah, and also on my phone. So I think an important part is that you'd want to, like, if you're holding phones as well, you want to be touching your phone, and no triggers should be happening. But then when you want, it triggers. So there's sort of yeah. You stop. Those are guys from my team. Okay. Just okay. So yeah, you also shouldn't need to wear it any tighter than you'd normally wear it. So for example, I could put it pretty loosely, and you'll see that I can put my 2 fingers through it, and it's still, oh no, it didn't work. Okay, wait, hold on. There, it still worked. So yeah, you can have it pretty relaxed. You could have it down here. Oh, okay, when it's loose and it's down there, it doesn't work that well. But I don't think most people, yeah, you get the point. It shouldn't need that that tight wearing. And also, and if you paid attention in the previous presentation, they mentioned something like, oh, workers don't want to be using hand tracking with gloves on if it's out in the cold and it's dangerous. So this actually works with gloves. Now, I don't have gloves with me, but if you have a glove, you can come to our booth and try if it works on your gloves. So yeah, it should also work when you're holding a pencil. So I think I also don't have a pencil here, but anyway, so it should work while being pretty robust. So because why not? I have 2 watches here that I'll just pass around, and you guys can try it yourself. So make sure, by the way, can I walk? Can I? Yes, okay. So make sure to wear it on your left hand. I don't know, you can try it here, good. Yeah, maybe you just pass it around, and left hand, and remember, like light and fast taps, you don't really need to squeeze at all. Like it doesn't work with squeezing. And also, please return them, thank you. Yes, we're not that well funded. No, we're pretty well funded, but not this well funded. Okay, so yes, 1 second. Anyone who wants to try? Okay, cool. And preferably on the left hand. Oh yeah, that is the left hand. Sorry, yes, that was it. Okay, cool. Now, how much time do I have left? 0. No, that's wrong. Okay, anyway. Yeah, so this is what I mean when I say we need to detect touch efficiently. You can think of this watch as being able to detect exactly when and where you've touched your fingers together. So that's the way of thinking. So we wanted to do it with the simplest hardware and software possible, so that we can make intuitive interactions on headsets more affordable to more people. So that's, again, the way of thinking. So yeah, that's it for our first implementation. It was a bit long. By the way, does it work? Yeah, not all the time. Okay, not all the time. Okay, come to meet afterwards, and we will check why that is. Okay, great. Cool. Okay, so now we have basically an essentially always available button, a touch button. What else can we do with it? Well, the next part is our second example, which is combining with eye tracking. So why? Well, oh, wait, can you hear me? Yes. Well, eyes are a great proxy for where our attention is in general. So of course, you've seen people try to use eye tracking as input. But till this day, most of the implementations are pretty unnatural because you need to stare at things for things to happen. I'm not sure if you've tried it, but I don't think that's that intuitive or that's that natural. So here we'd want to demonstrate that. Yeah. Well, actually, I already demonstrated to you, but I want to show you how fast I can go with just eye tracking. So it can actually be faster than a mouse, and I think that's the whole point here, which is that ideally future interactions in AR would actually be, and oh, check this out. Do you see that? So I had been walking around for so long, but then I came in and the ray still stayed where it was supposed to stay. So I think that was one of the points I wanted to make. So with eye tracking, you can be pretty fast. So let me just adjust the headset so the eyes sort of work here. So I'm just going to go through every single app, and it's basically faster than a mouse, and I can pop a lot of bubbles like that. So yeah. I guess the point here is you don't need, imagine if you stare, it would literally 10 times the time it takes to carry out these sorts of interactions. So, yeah. It's also super easy to learn because everyone, this comes really naturally to everyone. So if you take a step back, actually, I also want to emphasize, again, how we think about things. So this kind of makes sense if you think about it, to combine eyes with touch, right? Because when have we ever really interacted with the world with our eye movements alone? Like, never, right, in all of human history. It's just not what our brains have developed to be good at. And so, of course, you shouldn't expect interactions based on only eye tracking to be good. So I think that's what I want to sort of emphasize here. By contrast, though, the moment we touch something, that's when things usually happen in history, right? We apply forces onto things with our fingers, and that's what we've become good at. And this is why we think touch will keep playing an important part, an important role in the future of interactions. So again, this is the way to think about it. So yeah, with that, we're coming to our last interaction paradigm for this talk, and that is surface interactions. So this I haven't actually shown you yet. So the premise for this third one is that even though we've been showing how we don't necessarily need hand tracking for touch-based interactions, we do acknowledge that cameras will be there in the future of AR anyway to play whatever role it does. But even then, we think that touch is most likely way more efficiently detected using smartwatches than computer vision. So, because if you literally just think about it, you like for cameras to see this sort of micron level difference between hovering and touching, first of all, that event is blocked by the finger that's doing the touching on the table, just because of geometry. And then, and also, there's a huge difference between the sort of accuracies needed to track like general hand pose in the air like this versus detecting the difference between hovering and touch. So that, I think, is where if you have sort of vibration detecting watches, it'll be very helpful. By the way, AV guys, how much time do I have? Because this clock isn't working.
Take what you need to. It's
Okay, I'll try to wrap up. So to prepare for this future, I'd like to share this sort of hybrid touch sensing approach where you use hand tracking to determine where your hand is in general, but the watch tells you when you've touched the table. So just a note here, now the watch actually detects touching other surfaces rather than your own thumb. So that's a subtle difference here, but let me demonstrate. So here, I actually need to open a separate app. Apologies for the slight delay, but you will see demos in action. So I'm just going to open the app that is supposed to demonstrate using surfaces as an interaction modality. I'm just going to turn to surface tabs, and I think it's connected. Oh no, I just rejected the connection request. Wait 1 second. Let me try it again. Okay, beat tap. So we've made an app basically that has a sort of giant UI in front of you, which is actually controlled using hand tracking. So this cursor that you see here, that's hand tracking, right? So if you block the cameras, it will stop working. That's how you know it's hand tracking. But the actual detection of when you touch the table that I have in front of me is when you, tap your fingers on the table, and you probably can't see it, but maybe I could do it here, when you touch the carpet, the vibrations are being sent through your hand to the wristband, and that can be detected as a touch. Now, that means I don't think this is the future of interaction in my pose currently, but imagine a table where you can rest your hands and do these subtle movements that are simply too hard to be detected using conventional camera-based hand tracking, because these subtle movements they're just, the accuracies of hand tracking is larger than the actual magnitude of the movement. So you would have to actually like do this sort of poking, and that's what we want to avoid, because if you have your hands on a table, sort of that this sort of high poking motion defeats the whole purpose of keeping your hands on the table in a relaxed manner. So this, we think, is kind of a match made in heaven. So you just, you have sort of the best of both worlds, where you can get this sort of coarse hand positioning using basic hand tracking algorithms. And then this sort of detailed touch detection, that is using smartwatch sensors. So yeah. Now, the implications of this. Why am I showing you this? Well, I actually think that this, again, is probably a point where we should step back and ask ourselves. So if you are designing headsets with cameras already, just having a basic hand tracking algorithm running continuously will be good enough. Like that, and that's pretty great. Everyone can make a basic hand tracking algorithm with low finger precision. You don't need high finger precision for this anymore. And now, so with this, now everything becomes a touchscreen. Everything. Your other hand can be a touchscreen, the wall can be a touchscreen, the floor can be a touchscreen, your knee can be a touchscreen, without the need for complicated hand tracking algorithms. And as a consequence, of course, this means that you could bring, for example, your entire app ecosystem that's designed for touchscreens, like the iPad, and just port it now into AR and use it in the same way. So now you eliminate one aspect of the chicken and egg problem of AR adoption. So this is what we mean when we say touch will continue to be important. It just seems to be such an essential part of how we interact with things. And with that, we have covered all interaction paradigms I want to show you today. I hope I haven't been too boring. But the last few points that I want to make before I open up for questions is that we have a free touch SDK. So you can go online to doublepoint.com if you want to try these demos that I've been showing you, or visit us at our booth. And if you want to try out our evaluation kit, which is a bit more advanced, it comes with features like being able to try models of different sizes. So you can have, like, if you're an IMU provider, if you make IMUs and you have this computation unit in the IMU, you can ask us for like kilobyte-sized models, and we will give you one. And also, we can give you models that output tap strength as well. So if you want to test, light taps, meaning clicks, but then like strong taps, meaning double clicks, for example. And also, we can output tap probability. So you can actually set the threshold for like what is considered a tap or not. But for that, just ping me a message. And second, even though I've spent most of my time showing software for smartwatches, that's not the whole extent of what we do, of course. Because in the beginning, we wanted to start from the ground up and really see what's the best way to solve the problem. And so, of course, smartwatches weren't designed in the first place to solve this problem, so we have been considering and making custom wristbands. And for that also, just ping me a message. We have a few prototypes we can share with you. With that, I hope I've conveyed enough why we think touch is important and what you can do to detect it efficiently with existing smartwatches. That was basically my main message of today, so thank you very much. And questions, please. Thank you.
We only have time for one question.
One question.
One question.
Okay.
I saw this hand go up first, so I'm going here.
All right.
Hi, can you detect different fingers?
Yes, so we are working on that, but at the moment we tried to make one gesture very robust and sensitive. So, but we're working on that. Yes. I guess that was it, huh? Maybe one more. Okay, thank you.
Thank you. This is wonderful. How about swipes and other gestures?
Hell yeah. Okay, so basically, this is where we are reaching the limits of existing smartwatch sensors. We're also working on that. That's sort of what our custom wristbands are all about. So, okay, that was 2 questions. All right, everybody. All right, that was it. Thank you very much. Thank you.